Hello students, welcome to our channel. In this video, I am going to discuss about some graphs. Graphs regarding Boyle's law in the chapter called States of Matter. In your class 11 physics, you would have discussed some graphs. You would have discussed some equations like y is equals to mx, y is equals to mx plus c, y is equals to mx minus c, y is equals to minus mx plus c, y is equals to k by x. All those equations you would have discussed in your class 11, right? So now we want the curves, we want the graphs of those equations over here. Okay, so why we want that graphs means because in this chapter states of matter, gas laws are going to be only about the curves, they are only about the graphs. So now I'm going to discuss lots of curves regarding Boyle's law. So firstly I'll teach you the graphs of all these equations over here, and later on I'll discuss some graphs of Boyle's law. Now let's go with first one, that is y equals to mx. Okay, so have a look. Actually it is very easy and simple one, and I think definitely you might be knowing about this. Here I have to plot a graph between y and x axis. I need a curve between this y and x axis for the equation y is equals to mx, and the nature of the curve will be straight line passing through the origin. So this is the straight line which is passing through the origin, and this m is what we called as a, and the slope is going to be tan theta. Okay, slope is going to be tan theta. And what is this theta over here? Theta is the angle which this curve makes the angle with this positive x-axis in the anti-clockwise direction. So this is our theta. Now let us see the second equation, that is y equals to mx plus c. Here I am going to make a curve between y-axis and x-axis for the equation y is equals to mx plus c. So this c is what I called as a intercept here. Okay, this c is what I called as a intercept, and this y equals to mx plus c is again going to be a straight line. Okay, it is again going to be a straight line, but the straight line won't be passing through the origin. It cannot be passing through origin. So it will be starting somewhere above the origin. Okay, somewhere above the origin, but it would be a straight line. Okay, it would be a straight line and it is passing through the above the origin. Now let me tell you what is this intercept, what is this c is all about. C is the distance from the origin to the point where the curve starts. So C is the distance from the origin to a point where the curve starts. And do you know why I'm starting this curve above the horizon? What is the reason behind it? So just have a look. The sign of C is positive, right? So that's why I started curve C above the horizon. Okay. So due to the positive sign, due to the C is with positive sign, it will be started from above the origin. Similarly, now I'll talk about y equals to mx minus c. See this equation y equals to mx minus c. What would be the nature of the curve for this equation? What will be the nature of curve? The nature of the curve will be again a straight line. Okay, again it is straight line, but it is with a sign of intercept is negative. So here the intercept c having negative sign. What does it mean? The straight line won't be starting from the origin or above the origin. Okay, but it is going to start from below the origin. Okay, it is going to be start below the origin. Let's go for the next equation, that is y is equals to minus mx plus c. So the curve between y and x for this equation y is equals to minus mx plus c is going to be a straight line. Okay, it is going to be straight line, but the straight line won't be passing through the origin. Why is that? Why the straight line won't be passing through the origin? Because I have got intercept over here. and the slope is negative. Slope is negative means tan of theta is negative. That means the angle is obtuse, right? Tan of theta is negative means the angle is obtuse. So the curve is going to be like this. From here, from the origin to the point where the curve starts, it's going to be the intercept, right? And this is going to be theta over here. And the theta which makes the curve with the positive x-axis in the anti-clockwise direction like this. Okay, now let us see the fifth equation, that is y equals to k divided by x, where k is the constant. Okay, here k is constant, so we can say over here y and x are inversely proportional to each other. Correct? Y is inversely proportional to x over here. Whenever you have got two variables which will be inversely proportional to each other, like this, which we have in this equation, that curve is going to be rectangular hyperbola. Okay, that curve is going to be rectangular hyperbola. Now, I am going to discuss some curves regarding Boyle's law. See the first one. The first graph which I am making for you is that between pressure and volume. Okay, between pressure and volume, I need to make a curve. I need to plot a curve between pressure and volume. And what do you think about it? What do you think that the nature of curve between pressure and volume in Boyle's law? See, the basic equation of Boyle's law is P equals to K divided by V. And whenever I supposed to draw any curve regarding to Boyle's law, it will always starting with a basic equation. Okay, that is P is equals to K divided by V. You should need to remember this equation, that I am using this equation throughout this session. I mean, for every graphical representation of Boyle's law, I am going to use this equation as a basic equation in this session. Now, can I say this pressure is plotting on y-axis and the volume on x-axis, right? So pressure is on y-axis and volume is on x-axis. And here, instead of this pressure, can I simply write y? Okay, because pressure is on y-axis, right? So I can simply write y. So y is equals to k. And instead of this volume, can I write x over here? Because this volume on x-axis, right? So y is equals to k divided by x. Now I think you have got an idea about what is the nature of curve will be. That I have told you already. What is the curve for the equation y is equals to k divided by x? The nature of the curve for this pressure versus volume is going to be hyperbola, rectangular hyperbola. So this is the curve that is between pressure and volume and which is making at constant temperature. And let me tell you one more thing. When the temperature is kept constant, this plot that is between pressure and volume, which is called as isotherm. Okay, when the temperature is kept constant, this curve will be called as isotherm. So this was the curve number 1, and which is made at constant temperature between pressure and volume as per Boyle's law. Let's see one more graph, that is pressure versus 1 by V. So here I am plotting pressure along the y-axis and 1 by V along x-axis. And you know that whenever I am supposed to draw any curve regarding Boyle's law, I will always starting with basic equation. And what is our basic equation here? P is equals to K divided by V. Okay, I am plotting P on y-axis and 1 by V on x-axis. Now, can I write it like this? P is equals to K into 1 by V. Can I write it like this? Now, instead of P, can I write Y? Because I have plotted pressure on y-axis, right? And instead of 1 by V, can I write X, right? Because I have plotted 1 by V on x-axis, right? So I can write X in the place of 1 by V. And instead of K, can I write M, right? Instead of K, I can write m here. So finally, what is the equation that we get here? This equation is resembling with y is equals to mx, right? And we know that the nature of the curve for this equation y is equals to mx is going to be a straight line which is passing through an horizon, right? A straight line which is passing through an horizon, right? So this is the nature of curve between pressure and 1 by v. Okay, and the next one is p by v versus 1 by v square. Okay, so now I am plotting this p by v along the y axis, and I am plotting this 1 by v square along the x axis. And what do you think? What do you think will be the nature of the curve for this p by v versus 1 by v square? What do you think about it? Have a look. So we know that the basic equation of Boyle's law is p is equals to k by v, right? And you know that along the x-axis I am taking p by v, but over here I have only p. So now what I will be doing is I will be dividing this equation throughout this equation by v. Okay, if I am dividing throughout this equation by v, can I get the equation like p by v equals to k into 1 by v square? Can I get this equation by dividing throughout the above equation by v? And here instead of p by v, can I write y? Because p by v is plotted on the y axis. And instead of 1 by v square, can I write x? Why? Because on x axis I have plotted 1 by v square. And instead of k, can I write m? So the equation that I got here is y is equals to mx. So what will be the nature of the curve for this equation y is equals to mx? The nature of the curve is going to be the straight line. Okay, the straight line which is passing through the origin. So this will be your curve. Got it? This is the curve for p by v versus 1 by v square in our Boyle's law. Now see the fourth one, that is p by v versus 1 by v. And you know that our basic equation is p is equals to k by v. Along the y-axis, I am plotting p by v. Along the x-axis, I am plotting 1 by v. Now, I will be dividing throughout this equation with v. Then I will get p by v is equals to k into 1 by v whole square. Here, instead of p by v, I am taking y. And instead of 1 by v, that is 1 by v square, I am writing x square. So what is the equation that we got? I got y is equals to kx square. So for the equation y is equals to kx square, the nature of the curve is parabolic opening upwards. So this is going to be the nature of the curve between p by v versus 1 by v. Let's talk about one more curve regarding Boyle's law, and that is log p versus log v. And what would be the nature of the curve? What do you think about it? The first thing which you're supposed to know is along y-axis I am taking log p, and along x-axis I am taking log v. Okay, and since I have plotted a curve between log p and log v, I'll be starting with my basic equation. What is the basic equation? P is equals to k by v. The basic equation of Boyle's law is P is equals to k by v. But here I have got only log p. So now what I'll be simply doing is I'll be simply multiplying this equation by log. If I multiply this equation by log, what will happen? This is going to be log p is equals to log k divided by v. Now can I say this log of k by v is equals to log of m by n, right? And you know that log of m by n is log of m minus n, right? So it is going to be log of k minus log of v. Or can I write it, or can I reshuffle this equation like log of p is going to be minus log of v plus log of k, correct? So look at here. Now it is very easy. It became very easy. So that means instead of log of p, I can write y here. Why? Because on y axis I have taken log of p, and instead of log of v I can write x here. Why? Because on x axis I have taken log of v, and over here it is minus 1, plus instead of this log of k I can write c. So y is equals to minus mx plus c. So what would be the nature of the curve for this y is equal to minus mx plus c? In the beginning itself I have told you y is equals to minus mx plus c is going to be a straight line. It is going to be a straight line like this. And what would be the intercept over here? I have told you at the beginning, intercept is the distance from the origin to the point where the curve starts, right? So this distance is what we called as a intercept. And intercept value over here is log of k, right? So this is log of k. And let me tell you this angle. What is going to be this angle? Look at here. I am getting the slope value equals to minus 1, right? So from this equation, I got the slope value equals to minus 1, correct? Slope value is minus 1. And basically slope is what? Slope is tan theta. Slope is tan theta, and tan theta is equals to minus 1. That means this theta must be equal to 135 degrees, right? Because tan theta over here is going to be minus 1. So this angle you can also say 135 degrees. Got it? This is the nature of curve between log of p versus log of v. Okay? This is all about the graphical representation of Boyle's law. And if you want to learn more concepts regarding chemistry, do subscribe our channel, and thank you for watching.